4.4, our last section in chapter 4, we're going to be looking in this section at conversion between number bases. So we're going to write down some number base stuff today, and then we're going to talk more about places where you have already seen different bases and you maybe aren't even aware of it, and you use them daily. So to start with, our base 10 number system, we have 10 digits, but the number 10 is not a digit, it's a 2-digit number. Our base 10 number system starts at 0. If you think about the digits themselves, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are our 10 digits. And then when we run out of single digits, we start putting them in pairs, right? So we do things like 1, 0, the number 10, 11, 12. And eventually we run out of these digits because we hit 99 and we need a 3-digit number. And we call that 100, and the process continues. You're very familiar with our system. Some of the things that my math lab does, just so that you're aware, is that they don't often or maybe even never put the 0 at the beginning. They start with the number 1 like we start with counting numbers. So if they're doing that, that's fine. Just start with 1. It's okay. I like to put the number 0 in, and I will show it because I want you to see that it's one of the 10 digits. Base 5 numbers. So if there's no 10 as a digit in base 10, that means there's going to be no 5 in base 5. Okay, because we still start with 0, 1, 2, 3, 4. And when I get to 4, I've already got 5 digits, right? There's already 5 written there. There is no 5 in base 5. So when we run out of digits in base 10, we go to a 2-digit number, and we do that in base 5 as well. The number becomes 1, 0, and 1, 1, and 1, 2, and 1, 3. And when I get to 1, 4, I run out of digits. Right? There's no more numbers after 4. So what do you think happens after 1, 4? You get 2, 0. Yeah. What would be the biggest 2-digit number in base 5? 44. 4 anyway. Yeah. 44, 4, right? Because 4 is the biggest single-digit number. So the biggest 2-digit number would be 4, 4. And then I would get to a 3-digit number, and it would look an awful lot like 1, 0, 0. Base 7. 0, 1, 2. Where am I going to stop? 6. There's no 7 in base 7. Because once I get to 6, I have 7 digits, 0 through 6. So what happens after 6? You have 1, 0. And 1, 1 until we get to 1, 6. And after 1, 6, I get 2, 0. What is the biggest 2-digit number in base 7? 66. And after 6, 6, I would get 1, 0, 0, and I would continue. How is this next one different than the previous ones? It's bigger than 10, right? All the other ones were smaller than 10. We just sort of stopped and didn't write some of the different digits down. But in this one, I'm going to need more digits than I actually currently have. So here's how this resource, and this is a pretty common way of doing it. We're going to have the digits till 9, okay? And when we run out of digits, we go to the alphabet. Okay? So what's the first letter of our alphabet? A. How many digits are we going to need total, by the way? What base system am I in? 12. How many do I already have when I get to 9? I have 10 of them because I started with 0. So I need the A. A will be my digit that's representing the number 11. And I need one more, which would be B. This is representing the number 12. So I have all my same 9 or 10 digits through 9 that I had before, okay, 0 through 9, and then I also have an A and a B. So after I run out of digits, again, I go to 1, 0 and 1, 1, and I eventually run out when I get to 1, B, not 1, 9, because B is the biggest digit. So I get to 1B, and at that point I turn into 2, 0. What would be the biggest 2-digit number in base 12? BB. And after BB, we would have 100, and we'd continue. Okay? So we will develop this further when we meet again next time, all right?